Hey, what's happening, guys? What would you think about a Boxing Day kit build? My good friend Uncle Rob sent me a bunch of kits last year. This is one of them. The MQ2 smoke sensor natural gas alarm. Let's see what we got inside. So this is the MQ2 sensor. We've done a video on one of these before with an Arduino, so I won't get into it too much. Let's have a look at our circuit board here. So we got a speaker, we got our smoke sensor, we got an LM358 op amp, it's like a 10K pot, a couple of diodes, power in, out, and a relay. Okay, so you figured out what this does yet? So if this sensor goes off, and it should be adjustable by that pot there, it is going to make a sound and activate the relay so that you can turn something on or off. That's pretty neat. Let's see what else is in the kit here. Our standard piezo squeaker, speaker, whatever. One green LED, two red LEDs. I only see spots for two, but that's okay. Got some resistors here, some resistors here, some more assorted resistors. There's our relay. Songo, I knew it would be a Songo. This is a 5-volt relay. And if you look here, you can actually see the coil. They've diagrammed it there so you know how everything goes. Very nice. Got some rising block terminator clamps. And looks like a couple of transistors, or op amp. This could be a really simple, easy kit to build, and hopefully it'll be a fun kit. I've got another fun kit for you. Solder stick ring connectors. If you like to do automotive work or boat work, you know, whatever your hobby is, and you like to restore something that's got electronics in it, anything that you can do to terminate those wires as opposed to just sticking the wires and twisting them around a screw is going to greatly increase the reliability of your connection and decrease the resistivity of the connection. So in this case, we have some ring terminals. They are available from 22 down to 10 gauge. Yeah, you put your wire in there, you clamp it. These, I believe, are the heat shrink ones, so you can heat them up. They'll sink around your wire, insulate everything properly, and give you a nice professional finish. I'll put a link down below where you can get these. And thanks Solder Stick for sponsoring this video. All right, so we're always going to start where we start, which is the lowest components on the board, the resistors. But before we do that, never assume everything in your kit is okay. So I'll start out by testing the diodes. Make sure they work okay. Good. Doesn't matter which way you stick them in here. Good. Good. All right, so now we've got a couple of freewheeling resistors. You'd be better served to learn the resistor codes, but ain't nobody got time for that this morning. Here on Boxing Day, we just want to sit here and watch you build a kit. So that is a 10 ohm resistor. Is there a spot on this board for it? Right there. Well, how about that? All right. Check out this one. I think this one's a 10K. We'll find out for sure. Yep, 10K. So that goes with these guys. Let's see what this one is. Probably 2.2, I believe. Yeah, red, red, red. Yep. So I'm going to get all the resistors in. You don't have to watch that. All right, so they're all soldered in, nice and neat. All the resistors are facing the same way except for one, because I like to mess with my friend Barry. Well, I guess you could say there's one more resistor, this here 10K pot. But you see, that's more of a higher component. We don't want to put the higher components in until later. So next up, let's put this diode in. This is a 1N 4007, a standard rectification diode. And by that I mean it is an electronic one-way valve. Current can enter through the anode, that is the unmarked end, and exit through the cathode. It cannot go the other way. Well, it can, but if it does, something has gone wrong. You've reached what's called the breakdown voltage. But that is outside the scope of us just sitting around chit-chatting the day after Christmas. I refuse to use my brain again until the new year. Okay, so there's our diode. Now we have a socket for our IC. All right, let's get our IC socket in here. Make sure we line up the notch so the chip will be in the correct orientation. These sockets, I've always had a problem getting solder to stick to them quite well, so I'm just going to apply a little bit of Uncle Rob's Magic Solder Flux. If you're interested in Uncle Rob's Magic Solder Flux, just send me an email and I'll shoot you his email. I think he charges $5 a pen, which is really not bad. All right, let's get one of these legs tacked in here. Then the opposite one. So, what'd you get for Christmas? I got a weed eater, battery powered, absolutely terrifying attachment type weed eater. I got a leather hat to go with my leather jacket, which when I put it on, I look like a Klaus Miner from the Scorpions. Well, a fat Klaus Miner, but you get the idea. I want to start singing, want to rock you like a hurricane. Got a fifth of my favorite whiskey from the boy. So, you know, all in all good. All right. Let's go. This is pure one transistor. It's an 8050. Is that what that says? Can you read that? Come on. Hope that's what it says. The thumping you may or may not hear in the background is my washing machine. I got a load going this morning. Is it still morning? No. Started out in morning, but it is most definitely afternoon now. Oh, so I left you for a bit between when we did the resistors and now, because Blake came down for Christmas and we went to the nursing home to visit my great aunt and godmother in Wintersville, Ohio, which is just a little piece down the road. And as soon as we walked in the door, there's ceiling tiles all over the floor, water. I'm thinking, oh no. You know, because they know that everybody and their brother will be coming to visit their loved ones at the nursing home today. And they got this mess. I just like, oh, I feel so bad for you folks. And they're having a Christmas luncheon. And my aunt, who is starting to lose it, she's just like, well, I don't understand why we just can't start the luncheon now. Can't they just clean up the water? That capacitor is non-polarized, so it doesn't matter how we put it in. She had the lady come and explain to her that, in fact, the kitchen had flooded as well. And they were going to have to wait a little bit for their Christmas luncheon until they could find some place that was open and would cater them some food, which is not too hard. There's a couple restaurants, so I'm pretty sure Cracker Barrel's always open on Christmas. All right, our two diodes, D1 and D2. So power red. Okay, so power is supposed to be green. I was trying to decide which direction I was going to do it. Well, now I'm just trying to figure out. I can't read. Those markings are just, they're too small. I'm trying to figure out which leg is positive. So, what we'll do is we'll tone one out to ground. Real simple. So today's meter will be the Junctek ZT-QS9, which is a nice little clamp meter. We got it in continuity mode. So I'm going to go to the ground here. There we go. Inside is negative, or the cathode. That will be the short leg. Always starting with a clean tip. That applies in electronics and in life. Make sure we're sitting pretty. Here we are. We'll do the other one up. This is a nice little kit. And while I'm soldering this, I'm sitting here thinking how I'm going to test it and show you guys. I think probably the best way would be over on the stove in the kitchen. Right? Alright, now we'll do a red LED. Same as we did the green one. One leg at a time, sitting pretty. I haven't even used the PCB solder stand. All right, how about our sounder? Positive sides marked, positive, positive. We'll put them in like that, and I'm going to leave that cover on just because it makes it a little bit quieter. It's on there for when these get wave soldered. It protects from solder getting inside the device. Ow. I just launched that into, nope, it's still here. Thought I'd launched it into low Earth orbit, which means it'd never be seen again. There we are. Very nice. All right, let's put our potentiometer in, or some people call these trimmers. Doesn't matter what you call it, as long as it works, right? So far, so good. We'll put our MQ2 gas sensor in, but first let's go over the computer and we can talk a little bit about how it works. Okay, here's the data sheet on the MQ2 gas sensor. It says the MQ2 gas sensor is used to detect or monitor the concentration and presence of combustible gases in the air. It's sensitive to hydrogen, liquid petroleum, methane, carbon monoxide, that's good, alcohol, interesting, smoke, propane. I don't see natural gas on there. Help detect gas leaks, right? Okay. So how does it work? The MQ2 sensor is a metal oxide semiconductor, not unlike a MOSFET. It has a different purpose, but it uses the same base characteristics, and it is known as a chem resistor. That means it changes resistance based on the gases exposed to it. This type of sensor requires the gas to encounter the sensor for a chemical reaction to occur. There you go. It's super simple, but brilliant. So this is importantly, there's a heating element inside the sensor, and heating element, flammable gas. You want to be careful with these. So it has a stainless steel mesh on the outside of it, kind of like a spark arrest. This mesh is mounted to a bakelite base and the sensing mechanism. So I'll put a link to this down below if you're interested in learning more about the sensor, but I just wanted to give you an idea of how it works. All right, so now we know how our gas sensor works. So here becomes something very interesting. Which way do we put it in here? It fit quite nicely that way. And it fits quite nicely that way, and there's no instructions. So next thing I'm going to do is, let's zoom in here. I'm looking for like any sort of markings there. No. Well, back to the meter. There we go. We will connect this to ground. So that one there is ground. Now I'm going to run over to the computer and have a look. I'll be right back. I can't find any diagrams. This pin here is ground, I think. Come on. Yep, guess we just gotta hope for the best. Come on. Oh, man. That can take some heat. Wow. Yeah, I'm a little low actually, because it's been so cold lately. I've been running 360. There we go. That might help a little bit. Of course, I could be wrong, as I oftentimes am. See, this is where my anxiety gets me. I'm like, how am I going to tell if it's working or not? Like, I've got a 75-80% idea of how I'm going to test this. But now I got to worry about, did I put the sensor in the right way? Come on. Yep, she's in. So we put these power headers on. And it fell right out. Yeah, I might have to get the blue tack for those there. No, maybe not. Let's see. It's working okay. And that sensor is still hot, by the way, from soldering it in. Man, that thing just sucked the heat up. Wow. It's still hot. Looks good. That leaves us with what? Just the relay. Yep, just the relay. And the relay can only go in one way. Oh, that's a tight fit in those holes. Nice. So you can see right there that those two are attached to the relay. So if the sensor goes off, you can turn something off, it looks like. need our IC. My little pin straightener here. Line up the notch. All legs go in. No, look at that. I didn't line it up correctly. Now we got them all in, I think. Yep. Good, good, good. Let me hook up some power to it. All right, got the power supply set for 5 volts. Negative, positive. Turn the power supply output on. Yep, we got a power light, that's for sure. Let's check. Oh, it's gone off. Interesting. It is, holy shit, it's almost drawing a watt. Wow. I don't know why it's going off like that. There we go. And I can hear the relay click. All right, let me see. Might have an idea how we could test this. All right, as I was running around the kitchen, it occurred to me that when this went off, we didn't hear anything. So maybe I do need to remove that. Yeah, there's no alarm. Let's see. That might be making a noise. I couldn't tell you. I'm hearing in the high ranges. There it is. That's so weird. All right. So, let's move up here for a more wider over the overhead view. Here's my idea to test it. Some butane. See if we get anything. No. Nope. Well, so much for my idea to test it. The current has settled way down. It's now only about a half watt now. Initially, that high current was to heat up the sensor. So, let's bring our meter in here again. Put it back on continuity. And I'm going to probe the relay outputs there. I should be able to switch this guy on, right? But now it doesn't want to play. There we go. And this is off again. Ha ha ha! Come on. I cannot win. I can't. All right, go about your Boxing Day business. Thanks for hanging out with me. Feel free to like, comment, share. Don't forget to subscribe. Big thanks to all the patrons. Big thanks to you guys. Big thanks to Uncle Rob for sending this out. That's it. I'm out. Peace.